Dawson Bridge, located in Edmonton, Canada, is a 5-span through-truss bridge that was opened in 1912. The historic bridge required a new bridge deck, truss strengthening, and painting. SPS was selected for the bridge deck due to its light weight and strength. This allowed for an increase in the live load capacity, additional dead load with wider sidewalks, and significantly reduced the number of existing truss upgrades. Existing longitudinal stringers were removed, and new stringers were installed to meet the elevation and connection requirements for the slender, high-strength SPS bridge panels. One 112 SPS composite panels comprised of two 10mm weathering steel faceplates, a weathering steel perimeter bar frame, and a 25mm elastomer core were prefabricated off-site. Over 16,000 holes were pre-drilled in the SPS panels for connecting to the structure. This innovative design allowed for an all-bolted structure with no field welding. Following the installation of the new stringers, the SPS bridge panels were positioned in place for bolting. The prefabricated SPS panels were used as instant work platforms as soon as they were bolted in place. Erection equipment could immediately drive on the new bridge deck. The erection advanced quickly across the bridge using simple, light-duty equipment. Longitudinal splice plates were used to connect adjacent SPS deck panels with countersunk pre-tension bolts to the stringers below. At transverse deck points, splice plates, both top and bottom, were installed to meet sealing requirements and transfer negative moments to the supporting stringers. Prefabricated SPS panels with all bolted connections and instant load carrying capacity led to the quick 6-week deck replacement on the 236-meter or 776-foot-long bridge. After the deck installation was complete, the surface was blasted, the waterproof membrane was applied, followed by a tapered asphalt surface to allow for positive drainage. The complete renovation of this vital transportation link across the North Saskatchewan River, originally estimated to take at least 18 months using conventional means, was completed in one construction season and minimized disruption to the public.